Hello everyone, my name is Jester Keneguyen from the ICT 11, and today I'm going to show to you my report about computer programming 2. So it is presented by me, of course, Guyena Jester Ken A, course and section the ICT 11, and our professor is Professor Jessie Almiranes. So today I'm going to explain to you the different types of functions and syntax, and of course the arrays, especially the questions regarding on arrays. So let's get started. So there are four types in functions, or there are four types of functions with syntax. So usually these four types of functions are being used in programming in order to make your code, or in order to make your code function as well as how your codes are working together with functions. So it is useful in codes in order to work as well and in order to function it well. So the first function, we called it as no argument and no return value. So the second one is called no argument but the return value. The third one is argument but no return value. And the fourth one is called argument and return value. So no argument and return value and no return value. No argument and no return value. In this type, as the name suggests, it passes no arguments to the function and you print the output within the function. So there is no return value. So a great example for that is when we code something and then we input it in the domain, what happens to the function in the range, it will not return its value. So if we put a function or a value in the domain and then we wait for the codomain or the possible values in the possible outputs in the range will not return the value by itself to the domain again. So that is called no argument or no return value. It's like in maths, like if we put a value on x and then we want to get the value of y, it will not return to x because x and y are different. So it means that the value by itself are the same, but as we wait for the range, it will not return the value by itself to the domain. So next, we have no argument but the return value. So no argument but return value, in this type, it passes no arguments to the function, but there is a return value. So when we say no argument, it means we don't put an arguments like void in our code, but that code will perceives or it will returns a value by itself. So for example, we put an argument, we make a code that there's no argument and then we try to run it. Of course what happens is it doesn't have an argument, but there is a value that is returning. So it is important to know that this no argument, that this type of value or syntax will not return will not have an argument, but it will return some values. So next, argument but no return value. Argument but no return value, in this type of function, it passes arguments but there is no return value and it prints the output within the function. So it means there is an argument but no return value. There is a void, there is an int, there is a int main. There is a void within this code, but actually it doesn't return any values. There is an argument in your code or in your function. There is a syntax, but it doesn't return any values. So it is different from the last one that we've mentioned. So the last one is known as argument and return value. So this one has both properties and capabilities of running a code. So the definition of argument and return value is an argument and return value, but in this type of function, it passes arguments and there is also a return value. So if we input a value in our domain, of course, if we want to make or if we want your code to return the value itself to the domain or in the range, of course it will return it by itself. So it's like in maths too, that if you input something in your x, it will go back again. It will return. So it is important to know that this argument and return value are same in this type of syntax. So let us define what is an array. So an array is a collection of elements of the same type placed in contiguous memory locations that can be individually referenced by using an index to a unique identifier. 5 values of type int can be declared as an array without having to declare 5 different variables with each with its own identifier. So array is a collection of elements of the same type placed in continuous memory locations. So when we say an array, it is important in coding or programming because it collects some elements or data or input that we input usually in our code. So it is a memory or data that can be usually replaced and individually referenced by using an index with a unique identifier. So there are known 5 values of type int can be declared there in an array. So without having a declared 5 different variables. So here, we have something what we call as one-dimensional array. So conceptually, you think of a one-dimensional array as a row, where elements are stored one after another. So this is an example of array. As you can see, there are 1, 2, 3, 4, 5, 6, 6 blocks or 6 elements of array. There, you're gonna put or input your output there, input and output there, and there you will see the result of your arrays. So here's an example of one-dimensional array. So we put include, hashtag include studio.h, int main, and then bracket, int array. So we have total of 5, then I, and then we set some rules for it. So I is equals to 0, semicolon, I is less than 5, semicolon, and I plus plus. So it means it's true. It must be true. So here, it will print the elements of the array if we try to run this type of code. So this will be the result of the array that we make or the code that it is included there or inputted there. So we have, if we enter A, so first number, we got 11, 0, 11, enter A, another one, we got 22, another one, 34, and then 4, and then 34. So this is the total number that we got, or this is the result of the array that we got when we try to enter a certain key in our array. So next, we have two-dimensional array. When we say two-dimensional array, it is an array of arrays and it is known as 2D array. The two-dimensional array, in short, it is 2D. So the two-dimensional or 2D array in C programming or C++ is also known as matrix. So a matrix can be represented as table of rows and columns. In mathematics, we all know that matrices are different types of numbers placed in one table or one rows. There, if you want to get something or if you want to get a value or product, you need most of the time to multiply them or add them. So to get the total value of your matrices. Here, this is different. A matrix can be represented as table of rows and columns, but here codes are being replaced. So before we discuss more about two-dimensional arrays, let's have a look at the following C program. So here is the program that we've included in our two-dimensional array. So here, it will display the value that we've input here. So we put include hashtag include studio.h. Next, int main, semicolon. We have comments here, the 2D array declaration, counter variables for the loop, int I and j, integers. 4, this is the rules. I is equals to 0, semicolon, I is less than 2, semicolon, and I plus plus, which is true. And it must be true in order to function your code. So if this is true and if this code is working, of course the two-dimensional array elements are working as well. So this will be the result of your code here. So if we enter a value 0, it will result to 1. Next number, it will become 2. Next number, 3. Next number, 4. Next number, 5 and 6, and so on and so forth. So if we want to see a matrix number that we've made in our code, this is the result. The two-dimensional array elements 1, 2, 3, 4, 5, and 6. You just need to put a bracket here to call it a matrices or matrix. So next, we have something what we call the sequential search. Sequential search in C++ is also called a linear search. When we say linear search, it is direct search. This searching technique is very simple. To perform this technique, the user starts the loop from 0 index of an array to the last index of an array. it starts from the first index and compare the required value with the first value. So when we say sequential search, it is also known as linear search or direct search. Here, we start from the index of the first array to the last index of an array. So we start from the first until to the last and then go on or return to the first value until it ends or until it terminates the program or the code. So if the required value is found, it will show the result. Otherwise, compare the value of the next index and it will continue until the required value is found or loop completes without finding any value. Like what I've said, it will return, but if there is a rule within that code or within that sequential search, there it will stop, or that is the limitation of your loop or your index of an array. If your That's your limitation or your boundaries within your array that you've made or the code you've made. So this is the code that an example. This is an example or code of sequential search. So include iostream.h. Here we have an array which has a limitation of 5, or it has 5 arrays. So cout, enter 5 numbers to store in array. So enter the number you want to find. So required numbers found out at the location. So if we run this type of code, uh, what will happen is it will move forward, move forward, and then until it will return. So for example, you run something. Uh, Let me show to you using Paint. So for example, in the block of uh, here, you have a number here which is 6. So 1, 2, 3, 4, 5, 6. The first number that goes here will move here. And then if this one moves here, the other one will move here. This one. So it will repeat until it goes back to the first section. But if there is a rule or limitation or boundary within your code that you've made, of course, it will stop. But this is called a sequential search. It means that it is directly. So this is the reason. So why that code is being run or created. The above program will declare an integer array named R1 to assign the values input by the user. Then it will declare variable required to assign the value of a required number. It will declare variable location to store the location of the required value. The program uses only one for loop to search the number. The loop will run from 0 index to the last index of an array. Therefore, it will compare the element at the index 0 with the number user wanted to search. So it means that the order that the thing that you've been entered, the user number that he or she has been entered is comparing to the number there, the limitation of the value of the code. So if you enter 4, it will compare to the 5 last digit numbers in your code. So therefore, it will compare the element at the index 0 with the number user wanted to search. If both numbers are same, then it will assign the value of the loop variable to location variable. If it is the same, then it will look for the loop variable to the same variable location. If they does not match, then it will compare the value of a required number with the next index. So for example, it is 3. It will compare it to 5 or 4 or 2 or 1. But if it is same, for example, 5 and 5, it will find its location to the original location variable. It will locate, or it will find its original location. So the process will continue until the value found or loop completes without finding anything. Until it does not finishes its boundary or limit, it will run again and again. So next, we have something what we call the selection sort. So selection sort is a sorting algorithm that selects the smallest element from an unsorted list in each iteration and places that element at the beginning of the unsorted list. So I've mentioned before, the example is like this. So this is the first thing that you need to know in selection sort. So first is select first element as minimum. So next, compare minimum with the second element. If the second element is smaller than minimum, assign the second element as minimum. So if we have as this is the first minimum, this is the second minimum. So if we compare it, if we move this here and then move it here, this number that will go here is the last one. So if we move this 20 here and then 12 move here in the third column, and then here the number 2 here will move in the front. So compare minimum with the third element. Again, if the third element is smaller, then assign minimum to the third element, otherwise do nothing. The process goes until the last element. So this will happen here. So 20, 12. So it will move. The 12 will move here. And then the 10 will move here. 15 will move here. The 2 will go to the 20 until it goes, or it will repeat. It will repeat the whole algorithm, or it will repeat the whole sorting. So next, after each iteration, minimum is placed in the front of the unsorted list. So like what I've said, the 2 will go here, the 20 will also here. You can swap it based on what it is included here. So if 20 is here and then 2 is here, you can swap it. But the numbers here are constant, they are not changing as well. So swap the first with minimum. So 2 is here, 2 is here before, now it is in the first column. 20 is here in the first column, now it is in the last column. So you can change it, you can swap. Next, for each iteration, indexing starts from the first unsorted element. Step 1 to 3 are repeated until all the elements are placed at their correct positions. So here, so 20, 12, so 12 will go here, then next 10 will go to 15, and then 15 will go to 2, until it swap. So when 15 is going next to 2, the 2 will go in the first column, and then the 20 will go to the last column. It is called as swapping. So next, this is the last. When 15 is going to 20, the 2 will go in the front, and the 20 will go in the last column, which is already in place. So if you see that the 15 or the third column is going here in the last, stop it there or make it stop there as a constant. This is what we call a selection sorting, where you are going to move the numbers based on your code. It will move accordingly arithmetically with an algorithm, and then here what will happen is by loop it will move forward. It will move arithmetically. It will move sequentially based on how you make your code or how you make your program correctly. So I hope you learned something from this video. So uh, this is all about arrays, and this is all about computer programming. I hope you learn about something in these simple video instructions that I've made. Thank you so much, and God bless.